I rolled out of bed and I'm here. It's 8 in the morning for me. I took the long commute from my bed to my kitchen and I'm ready.
Nice.
So, Demetrius, you are the host, so you have the honors of, do your Demetrius thing.
I love it. First of all, I want to say thanks to Alexi for letting me jump in here and do this, because I've been watching the 5-hour marathons, the Friday 5-hour marathons, I guess we could say, for the last couple of weeks, and I just wanted to be a part of it. And he said, "You can come and host one of them," because we're already full for speakers, and we'll say that MLOps community collaborated. But in all seriousness, I think that what you got going on is pretty awesome, man. You're doing a great job. You are an incredible data scientist and community builder. Who would have thought?
Thank you.
And the other person on this call is also doing a great job. I see Elle doing some incredible stuff when it comes to the advocacy of how to be a better data scientist, how to bring a software engineering mindset into data science, how to do things in a more efficient way when it comes to just ML ops in general, I think. So I'm stoked to be on this call with you and hear what you've got to say. It is going to be a presentation, I think, I hope, because if it's not, I'll prepare some questions real fast, but it's a presentation, right?
Yeah, that's right.
All right, good. All right, so then I will hand it over to you and let you take over and tell us all about what you've came here for.
Cool. Thank you for the intro. That was lovely. So thanks for having me, and I'm just going to jump right in. So a little bit about me. So for most of the last decade, I worked in academic research in various areas of neuroscience. And one constant in my work is that I always do a lot of mathematical modeling, and I really enjoy excuses to use very big computers. And when I got my PhD last November, actually now it's more than one November ago, I was interested in how scientists in academia and industry use computers and how we're going to build tools that enable high quality science as our methods and data sets and problems all seem to be getting more complex. So I signed on as a data scientist at iterative.ai, and we're a small company that our flagship project is open source software called Data Version Control, or DVC. DVC is a tool that adapts version control systems like Git to data science. So we're kind of at the intersection of data science and DevOps. And one thing to note is that this is actually my last full day at Iterative. I'm joining the faculty at the University of Michigan School of Information, and so I will still remain involved in advocacy work and such. But my capacity is as a lecturer and research investigator here. So I'm really excited, and we're working on putting together an applied. We have an applied data science program and incorporating some of these tools into the education that a data scientist will get. So today I'm going to share a little bit about some of the ideas that are, have been on our minds for the last couple months, and a project that I'm really proud of coming out of Iterative. It's like a sister project to DVC. So I want to set the mood with a figure from a really strong case study.
I wanted to ask if you're sharing something with us right now.
I should be. Oh no. Okay. Here we go. There we go.
There it is.
Well, you didn't miss very much, other than that I had a slide that looked like this. It was extremely basic. Thank you for that. Okay, now I'm going to start with a figure. So this is a figure from one of my favorite case studies. It's a study of teams across Microsoft, and the authors are reporting that teams, whether they work on speech or search or ads, as long as there's some machine learning component involved in the workflow, they tend to follow a pretty similar workflow on these software projects. We've got, nine steps here. let's see, so we've got these steps here, and there's a lot of them, and we see some loops here. This might look kind of familiar to anybody that has worked on a data science project, even if it's a quite small one and you're not working on a Microsoft team on a product that's going to ship. This is kind of recognizable. And of course, there are a bunch of folks with different skill sets working on this. We have data engineers, symbolized by this happy, adorable piggy, collecting, cleaning, and labeling data. Data scientists are engineering features and then training and evaluating models. And software engineers are deploying and monitoring applications built around those models. And this organization is full of baby animals, and this is my ideal company. So I just wanted to share that with you all. Anyway, this is all fine if the project is linear, like a relay race, but it's almost never that way. So we know that excellent machine learning models rely on feedback, which means software engineers and data scientists might have to pass several modeling experiments back and forth. Plus, there's often, a big hit in your model's performance after your model's been in production for a little bit, concept drift and such. So we need some refinement over time. Data scientists need to be able to anticipate the system constraints of software engineers who will deploy their models, or you end up with the situation where you've developed something in your Jupyter notebook and then it won't work anywhere else in your production system. And everybody needs to be able to trace where your data came from, particularly if there's got to be some kind of audit. There are certain domains where this is even more essential, but I would argue it's essential everywhere because models are defined by the data they're trained on. And all of this back and forth can get very confusing very quickly. Now, even though machine learning is a new part of software engineering workflows, and it isn't always easy to incorporate, software engineering isn't a new discipline, on its own. We've had some time to learn. And in the field of DevOps, or, we've got development, operations, portmanteau, put them together, DevOps. This might have some lessons for us. So specifically, DevOps has had success bringing together developers and operations specialists. So there's some reason to hope that, maybe if we look at how this has worked out and what kind of practices have taken hold here, we can, find some common ground for engineers and data scientists too. And so I want to talk about the principle of continuous integration and delivery, which is one of the coolest and most important, core concepts in DevOps. And it's really changed the way that multidisciplinary teams run, is continuous integration, delivery, abbreviated CI/CD. So CI/CD is a practice that establishes collaboration rules between developers and operations specialists. So it's more of a culture than it is a specific technology, but it generally goes a bit like this. So when somebody makes a change in your source code for your project, a build will happen automatically, and then some tests will get run on that build. And if the build passes the test, the modified source code becomes a candidate to be merged into the main branch of your project. And the idea is that every action, like a git commit and then push, triggers feedback, and every round of feedback will produce a release candidate. So you're getting fast automatic tests and frequent feedback. And everybody on the team who can touch the code has access to this information. You don't have to wait for somebody else to come and test your code for you. So let's take a look at what's different when machine learning is part of the workflow. So we can now, instead of changing code, we also have to worry about changing data, because your machine learning model is influenced by your data, probably even more than your code. Data matters a lot. So if you change your data, you've changed your model. So it's no longer enough to just, track changes in code. In addition, we're not just building software, we're training models, and that can have some specialized requirements. You might need a high CPU, high RAM instance for that, or you might need a GPU. The hardware here can be a little bit different. And now, instead of just getting these kind of pass-fail answers back, we're evaluating a model, and we'll often get a summary of many different metrics. And if a model has improved, can be kind of subjective, or at least it's not easy to define unless you really know the domain. So for example, a model might go up on overall accuracy, but at the expense of some precision. And if that is acceptable for your use case, can require a data scientist to say, yeah, this is okay. So there are a few reasons why these kind of modifications aren't trivial for existing CI/CD systems. One is that version control can't always track changes in data sets. So data sets, which are frequently on the order of a gigabyte, 100 gigabytes, they don't fit in your Git repository, and Git tracking code is very commonly the way that, these changes trigger the CI loop. So data sets, versioning them is a problem. Then training models isn't like building software. It's, if you need a GPU, if you need an EC2 instance, then that is a barrier. And evaluating metrics is just more complicated. So what is pass fail? It might mean, we might need quite a lot of metrics summarized to get a real good picture of what's going on here. So what's going to be needed are tools that will extend these CI/CD practices from the domain of software engineering to machine learning. At least this is what I think is needed. And this is something that we're thinking about as we continue to develop DBC. And we're people that make tools. So I want to show you a tool approach that we've made, for introducing some of these changes. So here's a wish list for some of the features that we might want and that we set out to make if CI/CD is going to work for ML. We want to be able to version data like code. We want our CI system to be able to allocate whatever hardware is needed to train models. And we want metrics about model performance to be reported in a human readable format so data scientists and other team members can efficiently review them. So the work I'm going to show you is a collaboration with Dmitry Petrov, who's a DBC creator and co-founder of our company, David Ortega, developer, me, a data scientist. So, knowing what we want, how are we going to do it? Our team is really into the Git ecosystem, and we like Git tools because they're so well established in the software development community, and we think they can be adapted to work better for data science projects. So two services in particular have really caught our attention, and that's GitHub Actions and GitLab CI. These are systems designed for Git-centric continuous integration. And there's a tremendous overlap in what you can do with GitHub Actions and GitLab CI. So for the most part, I'm going to focus on GitHub Actions in this talk, but please keep in mind that everything I say and show you, you can also do with GitLab CI. So the project that we're working on is called Continuous Machine Learning. Two ways to follow our project. We have a GitHub repo, just kind of like the hub. We have a website, cml.dev. And so to kind of revisit this figure and show you where CML, continuous machine learning, fits in, this is the idea. GitHub Actions can help us with this part of the CI process. So automating model training and testing is something that GitHub Actions can do. And GitHub Actions is, it basically is a service that runs a workflow defined by you every time a triggering event happens, like a change is pushed to your project repository. And by default, the workflow would be run on runner machines provided by GitHub, but you can use your own machines too. We'll revisit that in a bit. And so CML is a library that's going to work with GitHub Actions or GitLab CI, kind of on this part of the of the workflow or the CI loop, to make GitHub Actions or GitLab CI work easier for data science projects. So I'm going to take us through the priorities that we laid out one by one and show you how we've handled them. So first, let's talk about providing feedback in the form of metric reports. So let's say we have a project on GitHub. We're using GitHub Actions to automate training and evaluating a model. We're going to create this YAML file in a special file path. It's always going to be in this .github workflows file, but you can call it whatever you want. And this is the secret sauce for any GitHub action. And here's where we lay out the workflow that would be carried out every time our repository detects a push. And, of course, some changes in the push. So a couple things to note here. We are going to pull a Docker container. We've got some triggers. So the trigger here is push. There's our Docker container. The Docker container is our Docker container. It's not special. You can do this without our Docker container too if you install some of the dependencies, but just for compactness, I'm showing you this with our Docker container. And so it's got Python, a couple other things that are nice to have for a data science project, and the CML functions. And here in the workflow, so we're going to say, okay, every time we've detected a change, we're going to run this Python train.py, so train a model. And then I'm doing some bash scripting here. And what it does is it's going to write a markdown report of things that are output by this training script. And I'm using some special CML functions, CML publish and CML send comment, that are going to help take outputs of our Python training script, which in this case are a text file full of model metrics and a confusion matrix, so evaluating on some test set data, and we're going to publish them. And what that looks like is that when you make a pull request, you get a report. And so here we have our model metrics. We have a visual. This is just a scikit-learn visual. It's not special. So this is a way that you're getting comments. You're getting reports about what's going on your runner in this visual format in your pull request. And so the hope is that this will make, what's going on in your, the machine learning aspect of your project, make sure you don't have regressions, make sure you like this change before you merge it into main, give you and your team a chance to discuss, give a bit more visibility to ways that the model may be changing. So let's take a closer look at what exactly gets run in the workflow. We have a training script that outputs a text file of metrics and a confusion matrix. Then we do some bash scripting with our helper functions to add the reported model accuracy and the confusion matrix to the report. And then we deliver that report, this markdown document, to the pull request as a comment. And here's another example where I'm using DVC to make a table comparing model performance metrics from the latest experiment with what's on the main branch of my project. So DVC has a function where it kind of is like giving you a git diff, but it's for model metrics, so that if you're specifying, if you have a machine learning model and it's being developed on multiple branches or commits of your project, you can, compare its performance. So what are some model metrics like accuracy, loss across different commits. So just sort of like a git diff, but for those metrics. So here what we're doing is we're using DVC metrics diff to calculate how metrics differ across branches of the project. And we're using DVC plots, and DVC plots are actually just a wrapper for Vega Lite plots. So DVC plots, and by that I mean Vega Lite plots, so comparing loss functions between branches. So what's on main and what's at the head of this branch. And so this table gets output to your pull request. So this is actually giving you a comparison. So previously we saw just, what's happening here. And this is actually a comparison between what's on the pull request and what's on your main. Here's another example with TensorBoard. So we wrote a helper function so that you'll get a link to your tensorboard.dev page where you can track your model training in real time. So even though your model is being trained on a runner, you can watch it, through a TensorBoard. So the point is that there's a ton of flexibility here. You can pretty much put anything that can go in a GitHub Markdown document into your pull request as a comment. So you could make your plots or your tables using whatever visualization library you prefer. So you could use Seaborn or ggplot or Vega or whatever. And likewise, any way of writing a table too. And even though the examples I've shown are Python, you do not have to use Python. It's all language agnostic. It's quite high level. You put files into the pull request. So you have a lot of leeway. So a couple ways that, we imagine these CML comments being used is, you can report about model training on remote machines. It gives you the possibility of defining like a really transparent, test result. So you could potentially put, you could put as many metrics as you want on one of these. And we hope it gives you some of the ability to review data and models like code. And we have a video series. I have to promote my video series here. I've been working on a video series. And so these are all use cases, and we make them each use cases into videos. And if you have a use case that you think is interesting and that you don't see represented here, just please ping me and maybe we can make one about it. So this is a way that we kind of give tutorials for these various ways of using it. So if you want to learn more, the videos are there to kind of be like demos. I think when I'm not even sure, this number might have changed, but we've got around 50,000 views on that. So it's going pretty well. Okay, priority. The next priority that we had was that we wanted to be able to version data like code. And we actually kind of have this because we previously developed DVC. So this is kind of a little intro to what DVC does. And DVC and CML are kind of separate open source projects. They don't have to be used together, but using DVC here kind of lets CML be, in my opinion, its most powerful, but you don't have to. But if you want to use DVC, this is kind of how it works. And it kind of had to come before CML because of this kind of data versioning is really important for CI/CD to work. So we wanted to be able to version data like code, and DVC helps us do this. So to be very clear about DVC, DVC extends Git version control. It is not a replacement for Git. You need Git to use DVC. So people ask me all the time if it's a replacement. It's not. It works with Git. So if you have a data set or a trained model file that would be prohibitively large for hosting on GitHub, you could track it with DVC. And the syntax is intentionally very similar to Git. You would add and push it. And here's what happens when you push. You pick whatever kind of cloud storage you like, or it could just be, a regular file server that you have ran locally. But you pick some storage that you'd like to be a data remote. So kind of like how you have a Git remote that's for your code, you're going to have a separate remote that's for your data, and it could also be models, just anything big. And DVC will coordinate sending a copy of your data to that remote. And on your local machine, DVC creates this lightweight metadata file that can be tracked with Git. This is a sample file, and it contains a hash that indexes the version of the data set as well as points to its location in cloud storage. So to use this with GitHub Actions, you have to pass some credentials to the workflow, which you can store as secrets, or in GitLab, these would be your CI/CD variables. Basically, we just need credentials. So if your DVC data remote is an S3 bucket, we just have to pass some credentials to your workflow, so that the runner can push and pull to that bucket. And then after you've set those up, you can set your workflow to run commands like DVC, pull, and push. So here's what's going on in this workflow. First, we are pulling data. We're going to go from the cloud. We're going to grab a CSV, and we're going to give it to the runner. So this is whatever machine is running your GitHub action. Then you might reproduce a workflow. So DVC repro is kind of like a make file. It's a DVC convention for linking together data sets, code, and model files, plus some parameters, turning it into a pipeline. But you can think of it a lot like a make file too. And then finally, we will do DVC push your trained model, and that goes to the cloud. So you can use this to track files, models and data sets that never get stored in your GitHub repository, so you're not beholden to those file size limits. And so a lot of people, some people prefer LFS, but some people prefer this because you can use it with whatever storage you want. It's just like you don't need a server. It's just your Google Drive or your S3 bucket, whatever. And so some of the consequences for this is that changes in your data set can trigger a GitHub action, even if that data set itself is DVC tracked, not Git tracked. So if your data set changed and then you do DVC add to, kind of record that, then that will update the meta file that is Git versioned. So basically now you can use this as a way to trigger a workflow, even though you don't have to stick your data file in your Git repository. Likewise, GitHub Actions can push and pull big artifacts to cloud storage. And that DVC push and pull is kind of a nice high level way of interfacing. So you don't have to like write out the address of your bucket or anything. You know, you don't have to hard code things. You can just use DVC push and pull. And data and model versions are linked to every model training run. So when you use this, you'll never have to worry about, okay, when I did this run, what was the state of the data set at this time? Because you have it versioned. And a potential benefit, because if we're using cloud storage, it gets closer to having, you know, less servers. So if you're using a bucket, you know, then you're not maintaining a file server. Although according to the warranty, GitHub Actions is not serverless, please note. So the third priority that I wanted to talk about was that we wanted to be able to allocate cloud resources to train models. And in our first release of CML, we did this with Docker machine, and it's really cool. And so the original idea here was that by using Docker machine, you can create a GitHub action that launches instances whenever a workflow is triggered. And so that means that you can, you know, have a workflow that will actually launch an EC2 instance, and it could be like EC2 with GPU or whatever you want. And then your job will run on that instance. And the idea here was that we could push to initiate training in the cloud. And so to me, it's really cool. You know, this is probably my favorite part. So you can provision and deploy the cloud resources of your choice, run your training job on them, and then your entire training setup is codified. And we're working on an upgrade to this, which is using Terraform. So Docker Machine is actually a deprecated project, and this is being redone with Terraform. And it's really, really cool. And in fact, we just did a pre-release. So the release has not happened yet, but we did a pre-release. And I would really like to show you very quickly what it looks like. It's so new. So what this will look like in your workflow is that you can use this function CML runner. And CML runner, this is all it takes. And this is launching, okay, on AWS, I want to be in this region. This is the type that I want. And this is just a label. So CML, you know, just I want in my dashboard, these instances will be labeled with this. And then you run a workflow. And so for this workflow, what I'm doing is I'm just setting up Python, and then I'm running training. And so basically this is all it takes to provision and deploy an instance on whatever you like. And then, you know, you can also add in CML functions, so then you can send something back from that EC2 instance to your pull request. So this is an example where we're doing that. You get a report from your EC2 instance. And you can also do this with a GPU. So let me show you. This has also not been released yet, but I just really want to show you. So this is the code now to get a GPU. So I'm asking for this G3 instance, and then we're using it to train a style transfer model. Let's see, I think I have a pull request with this. Yeah, so we're doing a style transfer model. This last one I did, there's not much of a difference in the style at all, but you can adjust some parameters. You can get the info from your GPU, and you can compare, you know, what does the style transfer look like on the different branches of your project. So what I'm really excited about is just like this, it's just a neat wrapper, and I can brag about it because it was made by David, not me. David is our developer, and I just think he did a beautiful job getting to a very high level place for provisioning these instances. Okay, hang on one sec. All right, there we go. So this is the example I showed, and previously this was about 30 lines of code longer than it will be now. Now everything is just this one CML runner, and you don't have to do anything with Docker machine. It's gotten very, very well wrapped. And this works, we're going to release this CML 0.3.0 release will come with Azure and AWS. So GCP is not supported yet, but it is of course on the roadmap, and this is in pre-release right now. So we're happy if you want to try it and report back to us about any bugs you find or things you wish were different. And another thing I really like about this is that your GPUs will turn off at the end, so you can set a timeout on them, at which point, if they don't get any more signals from GitHub or GitLab, they will turn off. So you don't have to be in your dashboard, and remember to turn anything off. And so, okay, so I want to show a use case now, actually zooming quite back out from, the GPUs and how cool I think that is. And this is a use case that I made with Jeremy Jordan, who's a data scientist and software engineer. And so we were inspired by this paper, Beyond Accuracy, Behavioral Testing of NLP Models with Checklist. And so this is, in my opinion, just a great paper. I was at the ACL meeting, and I think it won Best Paper Award. And the idea is that, you can have like a checklist of things that, does your model meet these requirements? And they can be things for, robustness to noise. It could be, how do they perform if we swap the genders of people in sentences? Kind of a way just to get a holistic picture of the behavior of your model, going beyond just reporting accuracy, beyond accuracy, as they say. So we took a test from this, and the idea is that we're writing a test for studying a trained NLP model. The test is, given some sentence A, like, I just love the new Honda I bought from Crystal, we could introduce a random typo to get this sentence A prime. So here I'm swapping, putting in right here, just a typo. There we go. And then, we can check for if we have a sentiment classifier, for example, and the model is this classifier F, we can test, okay, do we get the same sentiment predicted for these two sentences? We shouldn't expect it to drift that much on the basis of random perturbations. And if it does, then maybe it's not that robust, or it's maybe deciding on some really arbitrary features that we don't really think are compelling reasons to be deciding the sentiment. And so what we can do is now we made a workflow where we're going to run this test on a trained model. So here, we're not model training, we're only model evaluating. And so this is kind of an idea of maybe you did the training somewhere else or at another stage in the workflow. And then, you get to this point where you have a model and you basically want to make sure that you haven't regressed relative to what's on the main branch of the project. So here we're showing an example of switching an Albert model to a Distilbert model. These are just different flavors of TinyBERT, BERT being a very popular model in NLP right now. And so we run the test and we're reporting, the differences in performance. And we can see that we have very minimal changes in things like the accuracy. So, it doesn't look like we've regressed, even though we tried using this other model. And then we can print out some failure modes. So we can see examples where we added perturbations and the model changed its answer for what is the sentiment here. And it was just really catastrophically wrong, and it was very confident about being wrong. So like, for example, this sentence here, like such an inspiring car, the way it's perturbed, I think I could see that as potentially confusing. But then some of the other ones are really interesting, like the sales department is about as helpful, knowledgeable, and straightforward as I've ever seen at a car dealership. And here all that changed is we added a Z, and that's interesting why that suddenly flipped everything, why this Z overrules like the helpful, knowledgeable, and straightforward. I don't know, that would be something I'd want to investigate maybe. So that's our use case that we're proud of. And you could also kind of imagine this transfer to other domains, maybe like if you have, computer vision, maybe you're doing image segmentation, maybe we can print out some of the failure modes here, or we could get exemplars from different slices or categories of your data, and you have this kind of visual. So if you go kind of back to the beginning, we had some goals for reimagining CI/CD. We wanted to be able to version data like code. And we are using our other tool, DVC, for this. So DVC extends Git version control to datasets, and that kind of lays the groundwork for, for using CI/CD systems with data science projects. We wanted to let CI systems allocate cloud resources to train models. And, we've built this CML runner function to deploy cloud resources from GitHub Actions. And we wanted to provide feedback in the form of metric reports. So we have helper functions like these CML publish, CML send comment for writing reports to a pull request. And, all of this gives everybody on your team access to all of your, your data set, your models, your code. And, I think it's a great way to put everybody, having some shared conventions and shared places to test, to experiment, and, to keep models and data sets. And so this is, it's a bit of it's not just a tool. I mean, it's partially a tool, but it also represents, I think, like a shift in, what is a data scientist's responsibilities, and can they have, part of the model, the testing, regression testing, kind of treating it like software, and can they be in that flow too? And I think there's a lot of data scientists for whom that answer is yes. So thanks for listening. Follow us on social for more updates. And then I'm also interested always in collaboration. So if you'd like to collaborate, my research interests are software and infrastructure, data science research, effective teaching tools for junior data scientists, and methods for collaboration across research institutions. And since I'm a research investigator now, I have even more freedom than ever to pursue these things and grants. So just wanted to flag that for anybody listening. But yeah, please follow us on social. We're an active open source project. We would love to hear from you. Open an issue. Tell us what you like, what you don't like. Feature requests, always welcome. If you don't understand something, also tell us that. That's good feedback too. So thank you very much for coming to my talk. And I think this is a good point to take some questions.
All right. We've got some great questions in the Slido, if I'm pronouncing that correctly. Hopefully I am. The first one that I think we should talk about, and some of these you kind of touched on, so feel free to say, yeah, I think I've talked about that enough. But the first one I think is, what do you do when data is too large to download each time when runners are triggered?
Yep, that's a good question. And so we don't have like a special CML tool for this, but there are some ways that we're seeing, we're having some discussions with users who are facing this, and we're getting some ideas. And so if your data set is changing constantly, like every run it might be different, then you do want to download it every time, because that's kind of the only way to, really test it. But if your data set is static, then downloading like a few gigs of data every time you want to run can be pretty tiring and run up your budget, and it's not really worth it. So there's a couple ways to do this. You can, if you have a self-hosted runner, so a runner, like just a machine that you manage to be your runner, you could put this on like an EBS volume and just kind of mount it there. So it's like always accessible to the runner on a file path. If you're using DVC, DVC has a cache, so it can remember things that have been previously downloaded and prevent you from downloading them. And so as long as you are, always working on the same, as long as the cache is available to the runner and the data set hasn't changed, that would prevent you from doing this. So what you'd want is a self-hosted runner that you can configure to have access to the data locally so that you're not downloading it. So there are ways to do this. But in terms of a best practice, I think this is still kind of exploratory. So if you try this, I would really be interested to hear what worked and what didn't for you. And we also have some discussions about this on our Discord channel too. So that's another place worth dropping in.
Yeah, check out the Discord channel. Where can we find that? Do you have a link? We'll throw it in.
I don't have a link, but I think
it's or something.
Yeah, I can do that.
Yeah, for all those people that want to, or just Google search Discord DVC, and you'll probably be able to find it. So the next question we got here is, Does CML work better for tracking experimentation or more for final pull request review when all the experimentation is done and you're ready to merge?
Yeah, that's another question that it can be kind of up to you and your preferences. So for some people, having a Git commit for every experiment, they don't like it. Some people are fine with that. Other people think it clogs up their Git history and they don't like it. So that's kind of up to you. I don't think CML was designed primarily as an experiment tracker. You know, there are other tools for that. So DVC has an experiment tracker. There's plenty of experiment trackers out there too, like weights and biases and such, MLflow. And so actually CML is compatible with all of those. Like you can use whatever experiment tracker you like. And then kind of as this questioner alluded to, you could decide, I want to do all of my, you know, I want to tune my hyperparameters basically using like MLflow. And then I'm going to check in my final result of the day. And then maybe we will test it in a container and run some standardized tests and print it out, you know, in our GitHub repository. So either workflow is completely acceptable. And I do see quite a lot of people that don't want to do this for model, you know, searching the parameter space. And I think a good reason, you know, to consider doing a lot of exploration locally is that, you know, this is just slower than, you know, running something locally. Like if you have a job, it's faster, you know, unless we're at like the limits of jobs that take like, you know, a long time to run, like several hours, then it doesn't really matter. But when you're doing things that are kind of interactive and fast, like let me try this and see what happens to the accuracy, that like fast iteration is probably better when you can just like, you know, do that locally, because here there's always going to be, you know, some extra time for setting up the runner and such. It's just slower. Like things that might take, you know, a second or two are going to take GitHub Actions or GitLab CI like maybe a minute, you know, and that's just a general feature of anything that they'll do, not CML specifically. So I hope that helped a bit.
It did for me. Next question we got up, which has been highly upvoted. How do you manage CI config files when the data scientists are trying out different experiments, e.g. changes to metrics or any default outputs?
Interesting. Is there an example of like what kind of config file they're talking about?
Ooh, there isn't in here. And I think there's a bit of a delay. So by the time this gets to them and then they put it into the chat, and then it gets back to them with the answer, it's going to be delayed. But
if you have any guesses, because I don't think I've worked on a project that had like a data science config file. I don't think I know what that means exactly.
Interesting. Well, let's answer the next question. And then if they throw it in the questions while we're answering the next question, then we can answer it. So the next question on this list is, how would you recommend to get started with CI/CD pipelines? I want to learn more about them.
Yeah, okay, great question. I think the GitHub Actions getting started docs are really good. You can kind of get started with this without using anything data science. Like you can just make a pipeline that like is every time you run your code, every time you push a commit, is what I mean, you're going to verify that like 2 + 2 still equals 4. Like you can do things like that and just start getting the hang of like getting this kind of feedback. And then of course, I think my videos are a good way to learn. So we have a getting started video where we do like, you know, I think it's pretty gentle and it's about, if you've never seen this before, what it's like, because it's just kind of a new way of thinking, but it's really, really cool once you get started. So it's totally worth learning. So I would say the GitHub Actions getting started docs or my videos, I think are 2 places I might recommend.
I will second your videos for a great pace to learn. You do not need to be so shy about letting people know to check them out, because they're awesome videos, and you can tell by the way that the community and people have been watching them and eating them up. I think they add a lot of value, and it is, like you say, it's a great way to understand the framework and the way of thinking. So there is another question that you answered It is, can I use CML without DVC? And I'm going to take a stab at that and say, yes, you can, but CML works better with DVC. Did I get it
Yeah,
right?
yeah, I mean, it's not necessary. Like if you don't need it for the data versioning capacity, like that's kind of what DVC does. You don't have to. I mean, if you're using Git LFS and you're happy with that, you can use that with CML. Or, you know, there are other, like if you don't like DVC's experiment manager, you can pair this with another kind of, you know, experiment manager too. So they're definitely meant to be modular. I do think the real reason to use DVC and CML is because I think DVC really gracefully handles doing diffs across branches. So when you want to compare model metrics across branches, you want a table, you want a graph like that, like you can do that with some kind of ugly low-level scripting, but I think DVC does that at a nice high level. And I just think it's the smoothest interface for that.
So the latest question that just came through is about the competition for DVC. And this is always an interesting one. I'm going to see how you gracefully handle this question, Elle. 'Cause as a enthusiast for DVC, and they're keeping food and the lights on, everyone knows that you are very much for DVC and CML, but what are some other tools out there?
Yeah, okay. So there are a lot in this space. You know, there's a lot that's worth experimenting with. So DVC, as I've mentioned, if you're interested in an experiment manager, so something that's going to track like all of the different configurations that you've tried, you know, there I think you want to check out MLflow, Comet ML. I mean, there's actually quite a lot in this space. And so, you know, there's weights and biases.
Neptune, I think, does it. Neptune
Neptune.
AI.
Yeah.
Yeah, weights
And
and biases.
yeah, they all kind of have like a slightly different philosophy. And so I kind of feel like if one of them resonates with you, that's the one you should use because like, I mean, you should do the thing that you're going to stick with and you're going to actually record what you did in. I think DVC is kind of distinct from a lot of them in that it's, I mean, part of it is that like it's really modular. Like I think one of the reasons that we have DVC and CML and they're separate and they don't have to be used together is that we kind of like modular projects, whereas something like MLflow, like I do think MLflow covers a lot of like the model testing, you know, and getting you closer to production. Like they do that too. They just have a different philosophy for how they're going to do that. And they do it through a platform. And so that's going to work for some teams. And for ours is more about like, no platform, we're just going to have these modular tools and you mix and match them with whatever other tools you have in your stack. So, you know, this might work well for teams that already have like a really strong Git flow or they love continuous integration through, you know, some of these CI platforms that we've talked about. Like if that's already part of your software stack, then we think this can work. And if that's not a thing you like, then you might prefer the MLflow end-to-end experience.
So that begs the final question from me. What ways have you seen this being used in the stack? Like what are some other pieces of the stack that you've seen this being used well with?
Okay, so something really interesting to me is, so this capacity to write a comment, like a detailed comment, I was talking to a team where they use it, but not for machine learning at all. They just like the ability to write detailed comments after running a GitHub action. So they were doing like speed tests and then they would publish that to their, you know, their pull request with CML, which is so interesting to me. So we, you know, in fact, we have made CML, we're also releasing in the pre-release a GitHub action. So it's like even smaller than ever and you can just get the CML functions and like nothing else. So I suspect like we'll be seeing more people using it because I'm like, I don't do data science really at all. I just want to write pretty pull requests.
Oh, wow. Awesome. So last question, I guess somebody slipped one in on me. I wanted to be the last one, but they're wondering, does CML and DVC work for model and data monitoring purposes as well?
We definitely did not develop it with that in mind. I think you could. but it's kind of an off-label use. There's nothing wrong with that. You know, everything we do is just like engineering it together, you know, from a small team. And if you were to do that and you showed us, we would love it and think it's really cool. But we don't have our eyes on the monitoring aspect of the life cycle. We're really about development here, and that's what we were optimizing for. So in that way, I think you could, but you would be venturing into some uncharted territory there.
Use at your own risk. I love it. I really appreciate you taking the time to do this and school us on this. And I guess that's it. Those are all the questions.
Thanks.
So
And if this person with a config question, feel free to email me. I'm sorry that I'm not able to answer that.
yeah, it looks like we never got anything back about the CI config files when the data scientists are. We'll get that another time. They'll reach out and then you can do a whole presentation on that.
Yes.
Thank you. And I think Alexi's in here somewhere, or did he go?
Yes, I'm here.
There?
I was thinking actually, like you've been handling this, you handled that so well, so maybe I should ask you to do it more often.
Who are you talking about, Elle or me?
Well, actually, I was thinking about you, Demetrius, but yeah, who knows? If Elle, you are looking for some side activities, let me know.
Yeah, y'all are great hosts. I feel like I'm having like the radio talk show experience here.
The data science radio talk show experience. That's what you get with Alexi's community, the Data Talks Club. So cool, man. Well, I thank you for giving me this opportunity. And thanks again, Elle. I learned a bunch, even though I've been watching the videos. I kind of knew most of it.
All right. Bye.
Yeah, thanks. Right.